All right, part 3. Like, what in the world? What am I doing? What happened to me? Okay. All right, I don't know if I'm going to hook this on the other video. If it is, like, why was I wearing the different clothes? What happened? Okay, well, look. Okay, I forgot to tell you one other thing about half-life. There's a way to find... Sometimes they've asked you, I'll say, indicate how to determine the half-life from the graph. So let's just see. In the questions I went through, 1, 3, 4, 5, 6, 7, I added 8. So call this one 9. Question number 9. Another question. I need to add one more thing on to what we did before the other day on that 12-5 problem that we did, this big long problem. Okay, so indicate how to determine half-life using the graph. Using a graph. They might not tell you which one. They gave you all these graphs. Okay, there's a couple of ways to show the half-life with a graph. First of all, you can do this. If you find the graph of absorbance versus time, which is usually a curve. Now, of course, if it's for a first or a second order, it'll be a curve. If it's a zero order, then it will be a line, and it still works for that too. Okay, but to find the half-life, what you'll do is you could start, if you wanted to, from the very beginning. What was your initial molarity? Let's just say that the initial molarity was 2 molar. Well, let me make it 3 molar. Pretend that the original was 3 molar. Well, what you would do is you would go down the curve. You go down until you get to half of that. So half of 3 would be 1.50. So, if there's 1 here, 2 there. So, well, I don't know, something like that. So 1.50 might be right here. So you go to 1.50. You see, how long did it take to get from your original concentration, your initial molarity, all the way to 1.50 molarity, okay, right here. Then you go over here, you find 1.50 on the curve, and then where the curve hits, go straight down. That will be the half-life. Sometimes they ask you to draw a diagram like that or explain it. If they ask you to explain it, I would draw a diagram, even if they don't say draw it, because it's easier to say. Like the time it takes to go from 3 molar down to 1.50, that will be your half-life. Now, for that matter, if you want to pick another number, like the time to go from 2 molar, I guess 2 molar is right there, down to 1 molar. Okay, if I look at 2 molar and I say, okay, here's the time for 2 molar, and then here's the time for 1 molar. Okay, the time if I subtract these two numbers, like final time minus initial time, that will also give you the half-life. So if you start at time 0, at time 0, 3 molar, the easier is just to say, go to half of the original concentration, 3 to 1.50. But if you don't know that, you can go to any concentration you want. You can say, oh, let's just go from 2 to 1. Half of 2 is 1. To go from 2 to 1, and then you get the difference in those two times. Like maybe that was at 3 seconds, and that was at 5 seconds. So 5 minus 3 is 2. Right? Yeah, if I can do my math right. Okay, so that's one way to find half-life. This works with any 0, first, or second order. And even over here, I could say, well, okay, what was my original concentration? 5 molar or whatever. And then I go down to 2.5. I'll say, okay, well, at 2.50 molar, I'll go... That will be my time. So my half-life would be the time from time 0 to that. That's your half-life. Okay, that's one way to find the half-life of the graph. But there's another way. Okay. The other way will depend on the order of the reaction. There's actually 3 ways. The other will depend on the order of the reaction. First, let me talk about first order, because really first order, when they talk about half-life, it's like 99.9% sure it's going to be like first order. Now, could they do a second order? They could. But for first order, what you could do is, you could do what I showed you. That's one thing. Or another way you could also do it would be this. Like if they told you, indicate on this graph how you can determine half-life. All right, so remember, it's the natural log of A versus time. So, and that will be a straight line going down. So to find half-life, what you do, and it's weird, I mean, it's just kind of describing what I told you yesterday already. You find the slope of the line. So find the slope, which equals k. Or you find the slope of the line. Now, when you find the slope of this line, just always, anytime you do that, if you just find the slope real quick, you're doing it real fast, you're not using my equations, but if you just say, oh, the slope is equal to k, well, the slope here is negative, okay? So just remember, remember that in the equation, it says negative k, okay? Well, I could write that down. Actually, we'll probably use this equation. Okay, so when you find the slope, your slope will be negative, right? So, and your k. So negative slope equals negative k. What that tells you is your k has to be positive. Just your k's got to be positive. Since your slope is negative, that just takes care of it right there, your k. I mean, if I put in a negative, 1 there, negative 1 is positive. So, okay, all right, got that set. So what you do, here's how you explain it. The question was to explain how you could determine the half-life. You have to do the math, but you explain it. First, you find the slope of the line from, if it's a first order, and they want you to indicate how to find the half-life, find the slope of the line, natural log of a versus time. Know that slope is equal to k. And if you want to even say, negative slope equals negative k, that's okay. It equals k. Now you'll plug in k, and you'll plug in, you can plug in, as I told you, whatever number you want, really. You can just plug in 2 right there and 1 right there. Anything that goes by half, from there to there. If you wanted to plug in the original molarity, and then go to half of that molarity, you could. But the math might be a little bit more involved. It's easy to say, plug in k here, put a 2 there, and put a 1 there. And then so natural log of 1, natural log of 2, k, and solve for t, and t will be your half-life. All right, that's one way you can do it. That's kind of crazy to go through the steps, but you're explaining it. I mean, they might be more likely to ask you just to calculate it than to explain it. But they have done that. They have talked about explaining it. But then, if it is first order, there's even another way. And it's very simple. Find the slope of the line, and then the slope is equal to k, and plug it into this equation, 0.693 over k. This is probably the best answer. If it's a first order, just all you do is find the slope of the line of ln of a versus t. The slope will equal your k. Plug k into this equation, and you'll have the half-life. Now, if you put in a 2 here, and a 1 there, and k there, you're going to end up getting the same thing. I showed you that yesterday, that math. So those are 2 ways to find it. 3 ways. One is with the regular a versus time curve, and then as I showed you a moment ago, and the other is if you have this line, find the slope by either plugging it into this equation, you can find the time, or by plugging it into this equation, you can find the time, the half-life. Okay, now, if they have not asked to do this for a second or 0 order that I know of, maybe they asked second order once, but if they do, what you'll do, you'll just take those equations, you do the same thing I just told you. So go to the graph of, in this case, just say, actually this is going to be a positive one on that one. Go to this graph of and find the slope of this, okay, find the slope, and now you'll plug it into this equation, positive kt, and the same thing, plug in initially 1, final 2, and then plug in the k that you get from the slope, and you'll find the half-life. And if it's 0 order, 0 order would just be the same thing, but it's a negative again for that one. I'm writing this so fast and messy. Oh, it's not a negative 1, sorry. Okay, second order. So second and 0 order, maybe I've seen second somewhere before. I don't know if it was on the AP, but 0 I've never seen. But anyway, the same way, just make sure you use the right equation. Negative kt for the 0 order, positive kt for the second order. Okay, all right, wow. That's a lot of material, I know. But you guys, I think that is everything I've ever found that they could ever ask you on this integrated rate law kind of question. Like that. If you see one like that with graphs and all, you ought to be able to blow that away, and you'll be ready for the quiz on this. Okay, so I'll see you guys later.